evening, everyone, and welcome to In the Know with Kat Bobino, and with my very charismatic, adorable, talented, energetic, and sometimes reluctant co-host, Mr. Carter Williams. Mr. Carter is being quite talkative tonight, but we are waiting for my guest, Dr. Fry, who's going to be joining us shortly, and he's going to be talking about doing biochemistry with youth around the age of 10. And so it's very interesting to hear of someone who is teaching such an elaborate, what's the word I want to use? Goodness, they say pregnancy brain, but I think birth brain is worse. Okay, he is joining us now. Welcome, Dr. Fry, to In the Know with Kat Bobino.
Hi there.
Oh, there you are. Hi, how are you doing?
Hi. Oh, you have a little visitor here. How are you?
Yes, this is my son. He's 2 months old, so he gets to hang up here with me while we do this.
Very cute. Thank you. We have a 3-year-old here.
Oh, congratulations.
He just went to sleep, so.
Well, I'm not that lucky, not yet.
Yeah.
So thank you for joining us on the podcast.
Thank you so much for having me. It's really nice to be invited.
Oh, absolutely, absolutely. So yes, on the podcast, we talk about all things science, tech, engineering, and math. And I love your profile on Instagram talking about biochemistry.
Thank you.
Yeah, can you tell us a little bit more about that part?
Yeah, sure. So I'm so glad you found me on Instagram. We have a beautiful page, which actually one of my former students helps me kind of curate it and try to express to people what I'm doing with this biochemistry literacy project. So basically what I'm doing is, so I'm a professor at St. Peter's University in Jersey City, but my real passion project is bringing biochemistry to a level that's understandable by elementary and junior high kids, basically. So I'm trying to not only like democratize biochemistry and move it out of a elite graduate school or pre-med sort of frame of reference, and allow really anyone to understand what it is and appreciate it. So that's the general idea of what I'm trying to do with biochemistry literacy.
Nice. Yes. So as a biology major, I do remember taking biochemistry many, many years ago. And for you to be able to break it down to our youth is amazing.
Yeah. So with the sort of a special kind of a approach that I'm taking, I'm using visualizations, modeling, computer modeling, to make the subject, first of all, very appealing and kind of intriguing to the kids, but also make it just very accessible. And it's really surprising the level that the kids can get to because of the different parts that go into the methodology, some of the unique methodologies and styles that I have. And also the content itself. I mean, kids don't ever see this material like ever until they get to maybe late high school, college, or even after that. So it's just a very unique program. And unfortunately, I feel like I'm the only one in this space. Well, fortunately or unfortunately, but I'm hoping that more people find out about it. That's why I'm so glad that you asked to talk to me, because I'm always trying to get more people involved because it's really a wonderful program, and we're trying to, get it out into the world.
Awesome. So let's talk about you and how you
Sure.
even got to this space. So can you give us a little bit of your background?
Sure. So I actually started college as a music major. I was actually down in Temple in Philadelphia at the Esther Boyer School of Music. And I was always torn between music and science, both basically throughout my high school life. And I eventually settled on music. But I sort of started to hear and see things that my pre-med friends were learning. They were looking at crystal structures of proteins, and they were like, they had these model sets, which I really liked. And I was just like, I wonder what those things are. I wanted to know more about that. So I began to move towards science again. I transferred to Binghamton University back in New York, where I'm from, and I did a biochemistry major there. I had a very supportive research professor who encouraged me to apply to grad schools. I never thought that I would get into any of these elite grad schools, but she really pushed me to do it. And I ended up getting into Yale, and it's hard to say no to a Yale acceptance letter. So I ended up going to Yale for my PhD, and I was there for about 7 years. I had an amazing boss who basically was running a protein folding lab where we were looking at protein structures. They were inventing new kinds of proteins out of unnatural amino acids. My project was on a fluorescent sensor for protein folding. So all these kind of exotic seeming concepts. But as I was going through the years, I was thinking, there's no reason that more people couldn't know about these things. Why did I have to wait until I was in my mid-20s to know this? This is stuff that really everyone should know about. Everyone should know what proteins are, how this, what makes up the cell, how living things work. Why do we have to wait so long? So I began to create these pilot classes basically out of nothing. I was advertising on Craigslist back in the day for free biochemistry classes from a Yale PhD. Come send your kids to my classroom at the Peabody Museum, and I will teach your kids this experimental curriculum. And surprisingly, people sent their kids and dropped them off and left. And I was able to, basically hone my, teaching skills and figure out what kids wanted to know. And that's how it all started. I then had an amazing friend who was also a musician who was in the New Haven public schools. And he actually got me my first connection with a school where I was able to try this stuff out in a classroom. And we saw that, this is really resonating with the kids. And even though it's so unusual and it's not what people expect kids to be doing, but I really believe that it should be there after these experiences. After Yale, I did just some regular science postdoc. I went to the Weizmann Institute in Israel for 3 years, where I worked in also another amazing lab. When I came back to the United States, as a professor, in New Jersey, I really felt, okay, now I'm a professor, maybe we can really get this project off the ground. And I began to, try to network with some education professors and try to connect with some schools. And it was very, very tough to figure out how to do it. But after years and years, we eventually found some schools that would allow me to run long-term programs and do some studies and do what I always wanted to do with this. We did some documentaries, and then after that, it's been kind of getting off the ground, getting popular with homeschoolers and other schools. So that's where we're at right now, and I'll talk to you more about that, obviously. But that's kind of the meandering journey to get to the level that we're at right now.
Well, that's a lot. That is a lot. But we'll break it down a little bit. But sure. Being a music person who was also
okay, yeah. Start from there.
Yeah, we'll start there. It's cool though, because it's STEAM instead of STEM, and adding the art into it. And a lot of times people don't realize how much art, especially music, resonates with science and technology. So I'm pretty sure you had a good, what's the word I want to use? A good way of merging the two.
Yeah, and some people always ask me, how do I do it? How does the method work where you can reach these very young students? And I think that's part of the secret, that I don't come from a typical science background. I come from more of the STEAM arts background. I'm also into art as well. So I'm kind of merging the pedagogies of art and music into science, and that makes for a really different sort of class than people are used to seeing. So I get some kind of prejudicial criticism, oh, I'm just droning on, lecturing, giving kids a college course, and why would anyone do that? People have asked me, why am I stealing these children's childhood? And it's really strange that people would have these kinds of ways of thinking of what I'm doing. But really what I'm doing, it's a very multifaceted, artistically influenced way of teaching And I bring my background to that too. You know, how do you learn art is by copying and trying to be creative and kind of experimenting and adding to things. How do you learn music? You have a certain, you know, way of practicing, and you have like a master teacher who's giving you bits and pieces, and they have this like big plan about how to turn you into a musician. And I bring that kind of idea to the science curriculum. It's very different from what you might have experienced in high school or other places. So that's one of the interesting parts of my background. The other part is that in Temple, I actually worked in an early childhood music institute, which was basically founded by this researcher named Gordon, and it's actually this Gordon music theory. And in my freshman year, I worked in this Gordon theory school where very little kids were learning music in a very different way. They're learning modal music, they're learning non-Western rhythms and things like that. And that kind of got me thinking, maybe there's like other ways of teaching that most people don't think of. So in a way, I was very influenced by this experience in the Gordon Learning Centers. So I thought maybe I can make my own version in science that kind of brings complex material down to the level that kids can understand.
That's really cool. So as you know, I do the podcast live on Facebook so that I can have people comment. Sure. So I have one comment that's saying, is this STEAM, which is STEAM with 2 M's, and saying that that's art, and the second one is music, which I don't think I've ever heard of. Have you heard of that?
You know, it would be interesting to have the music included. Yeah, that's true. And, you know, one interesting thing about chemistry, and this came up, you know, I run Zoom classes. I just had a Zoom class a couple hours ago. And one of the things that actually I have a lot of very accomplished musicians in these classes. For some reason, musicians are drawn to this. I mean, it's not really surprising, I guess. But one of the things about chemistry is that chemistry, you know, the electron orbitals are they're waves, and they're part of a harmonic series. Actually, the periodic table is actually a reflection of the harmonic series. So there's a lot of even very direct parallels between music and chemistry. That's kind of surprising. Am I able to do a screen share for people to see what I'm doing, or is this just sound right now? Because I could show.
Let me see if we can give you access to screen sharing.
Okay, because I could show you some very steamy kind of things right now.
Yeah.
Just some very beautiful. You can kind of see how beautiful chemistry can be. So if you want to later, we can show some.
My producer got you access, so you now have access.
Let's see if it works. Okay, I'm going to try to do this. This is all very kind of on the fly right here. But so let's just see how beautiful chemistry can be. We were just talking about the coronavirus spike protein. So I don't know if you guys can see this, but this is those triangular projections that are always coming out of the coronavirus picture that you see, those little red triangles, which I think is probably pretty famous right now. I kind of made it a rainbow color, but this is the essence of what we learn in the biochemistry literacy curriculum. They're deconstructing this and learning what these different pieces are. What are these spirals? What are all these like loop-de-loops mean? And what we have right here is actually the UK variant. So we know that there's a new version of the virus that is a little bit more, you know, spreads easier. And the difference between the old one, so here's the new one. The new one has these rings on it, these tyrosine rings, which is an amino acid. This is the mutation. So when you hear the new variant, that's what the new variant is. If we look at the old one, and I have this measurement here, which I need to kind of get rid of, but the old one, instead of those rings, it just has this thing. It has an asparagine amino acid. So the difference between the classic coronavirus is this particular amino acid, and then the new one has this ring on it, and for whatever reason, that's making it worse for us. So, you know, these kinds of structures, this is why I got into chemistry, because I saw a poster in the biology department at Temple, and I wanted to know what this was, like this protein crystal structure. I just thought it was amazing, like how does something like that exist? And I really wanted to, you know, learn about what it is. And in my program, we use modeling tools like this, and the kids explore it. And after several weeks, they really know what this is. They really have a command of what what they're looking at there, which is really, even for me, it's surprising they're able to do it. I'm always shocked when they start talking like a college student. It's really incredible. And I know the parents are also like kind of a little bit freaked out because they don't expect their kids to be getting to that level so fast. So it's really cool. I mean, kids really want to know this stuff, which is the bottom line.
Yeah, and that is very true. I mean, we always talk about kids, more so his age and a little bit older, but kids are sponges and they're open to learning. And if you just give them that opportunity to learn something that even we deem is for graduates or college age or graduate students, you never know what they're capable of if you just give them that door of opportunity.
For sure. Yep.
So that's really cool. And I'm loving all of those, all the pictures that you just showed us and the explanation. And I just implore anybody watching it on Facebook, if you have questions, let me know. But that was from Melissa, who had said the STEAM with the extra M. And Steve said, these are all great ideas. So you're already getting people in on this coast, West Coast, and Melissa, who's in Australia, watching and learning more and more about this.
Nice. I should tell you that we have so this is also, let me tell you one other thing about this. As a professor, I designed this program as an academic project. I thought that we were going to be able to get maybe NSF funding or some government funding to bring this to schools. This started off in public schools. I thought this was going to kind of take off there. We do have some public schools that are using it. There's even another one that I'm going to talk to tomorrow, but it's really turned out to be a homeschool thing at this point, especially because of COVID. So, so it is sort of a something that I try to have homeschoolers use, and we do have lots of Australians using it. Actually, the project is actually distributed by some homeschool groups in Australia. So I have tons of Australians using it. Of course, many people in California using it. So yes, there's an opportunity for anyone to find out about this and become part of this actually.
Oh, that's awesome. Okay, well, I'm sure if anyone, like I said, has questions, they can always let us know throughout this or even after, but we'll get back to you and talk about your transition. You said you went to Yale, but that was something you weren't expecting. So how did that happen?
Yeah, I mean, so I worked in a couple of synthetic organic chemistry labs in my undergrad institution. And, I had good grades, but I didn't ever think about going to an elite grad school. I really didn't honestly know what I was going to do after college. I thought I was going to join a drug company as a bench chemist and help make drugs or whatever they needed me to do. But I found out about grad school through my advisor, Rebecca Kissling, who's still there. And she just said, Dan, just go apply to Yale, Harvard, UPenn, just try it. You'll get into something. I was like, okay, I'll try it. And I amazingly got into certain programs, and I had a choice of where to go. The one thing that a lot of people don't realize about going to grad school for chemistry or biology or physics is that these are funded programs. So you don't actually pay for those things. A lot of people think you have to be like a millionaire to go to Yale for grad school. It's couldn't be farther than the truth. They're paying you to go there because you're a worker. You're doing research for years. You're teaching for them, and it's almost like having a job or an internship. So I was able to go. I was able to become financially independent to some extent because right out of college I got basically my own life. And it was an amazing adventure to be at Yale, to be in the footsteps of so many great people and the history. And that actually is part of what made me do this as well, because you're aware of all the amazing people that were there, and you want to do something like that. You want to see how can you live up to what you have become now. What can you do that, and also what can you do to go beyond yourself? And that's also a big theme of this project. This is it's not just about, a lot of the Ph.D. World. It's about getting papers, getting tenure, getting your promotion. And unfortunately, or to my, I don't know what you want to say, but this is about more than that. This is about trying to change the world, trying to change what education is. And you see it in these little kids that are doing this program that, they're on a different trajectory now with their lives, they're never going to be the same after that. And that's really what this is about. And even though it's been you know, there's other things that I may have been able to do that would have maybe been more successful, but this is what I'm going to do because I think it's important, and I actually couldn't think of anything more important that I would be able to do. So that's why I keep doing it.
Oh yeah, absolutely. I think that, making sure the next generation has a good understanding or a great understanding of what's happening in the world and what's happening in STEM is always an important job and important career opportunity.
Yeah.
I mean, that's one of the reasons why I do the podcast.
Of course, yeah.
Of course, it's going to be adults mostly listening to it, but it's to give students an opportunity to see a multitude of people in jobs that they didn't even know probably existed.
For sure.
Or
yeah.
creating your own thing, even with STEM.
Yeah.
So I did have a question from the audience.
Okay.
If this is something that you have an awareness with, is how effective is the vaccine that is out against the mutated strain?
Yeah, I'm not even when you talk to virologists or epidemiologists, they're like, we don't want to say. But it seems like the one that I just showed you, the new variants are point mutations. So there's like one very small part of the protein has been changed. So when that kind of thing happens, it's unlikely that it will have a big effect on how the vaccine works. And obviously we don't know, scientists want to say things that are backed up by data. So we don't know everything yet, but I think it would be surprising that a point mutation would ruin the vaccine. Of course, if those point mutations start to add up, then it can start to become a problem. So as more mutations accumulate in the genome, it's going to be a problem. So the idea is we got to get rid of this sooner than later and not let it fester for years and let the thing mutate into something totally different. Also, right. the fact that we have the RNA vaccine, this very new kind of vaccine, everyone's generating these polyclonal antibodies. So the antibodies are attacking the spike protein from all different directions. So if one part of the protein has a change, another antibody will probably be fine on the other side. So I think that's why people tend to not be worried about these, most of them anyway, but we'll see what happens, I guess.
We'll definitely see. I mean, that's always, I always tell people I'm not a virologist. I have no clue, I don't study viruses, never studied viruses. Everything I've ever studied was alive and well at this point. So it's not my cup of tea. I have no idea. But so we got to thank you for all the knowledge that you're giving. But I do want to see if you would break down for the audience, because not everyone is in STEM, and I don't want to assume what everybody knows. Sure. So when you're talking about proteins, can you explain proteins in the body for us?
Yeah. So if I can do a screen share again, I have a little thing lying around here. It would help you see what I was doing. So sure. I think, oops, I didn't want to show you that. No, I didn't. Sorry, I didn't want a screen share. I wanted to.
Oh, okay.
Me. Me is fine. So you might have noticed on that structure that I showed you before, there were a lot of those twisty things, those helical loops and things like that. So that's actually a chemical shorthand. It's almost like a stenographer is like a court stenographer is like writing down like shortened versions of the words, or a cartoon version of a real picture. So those spirals are actually representations of polymers of atoms. Okay. So if you saw this, so I kind of superimposed a spiral on here, but you can see that at its core, at its true, higher resolution, it's just made of carbons and nitrogens. So the black ones are carbons, the red ones are oxygens, the blue ones are nitrogens, white ones are hydrogens. So this is the peptide. This is the peptide that's been curled up into a coil or a helix. So that's what proteins are. Proteins are made of basically very simple things. They're made of a few different kinds of atoms, basically 5 different kinds of atoms, because there's also sulfurs. And that's what proteins are. And they're just very large molecules that have the ability to fold together into these complex machine-like objects that not just have a certain shape to them, but have a certain charge to them. They can move and they can perform chemical reactions. The spike protein can help to fuse the viral membrane with the human cell membrane. So they're little tiny machines basically, but they're just made of everyday atoms, just like, anything else. I mean, plastic is made of the similar atoms as a protein. It's really amazing how similar everything is at that level. Although the building blocks are different, the monomers are different to make the polymer. But that's what proteins are in a very quick way. Very long, complicated molecules that fold up into a special shape. And proteins do everything. Proteins are doing photosynthesis in plants. That's the photosystem proteins. Proteins are, our muscles are moving. Those are proteins. You know, everything interesting in biology basically is done by a protein. So there's a protein for that. Basically, it can be your answer when you want to know how something works. Like there's a protein for that.
Gotcha. Well, we got a comment from Melissa. She says, I agree. It is super important that accessible understanding of STEAM with 2 M's is shared by the most knowledgeable and passionate people to others, like Dr. Fry.
Okay, thank you.
Yeah, that is awesome. So thank you, Melissa, for that. So you went from music to science to biochemistry to Yale. And how did you get to Isreal?
So let's see. I'd been on a trip there. I was fast. You know, I'm also, as a kind of interested person, I'm also really interested in, you know, social things, history, geography. I really love geography, honestly. I like traveling. And we got an opportunity to do postdocs there. It was just kind of like almost like random. There was someone speaking at Yale, and actually my wife's also a scientist, and she just she's actually, I don't know if anyone knows Adi Yonath. She got the Nobel Prize for crystallizing the ribosome a few years ago. So a very, very famous person. Her student was this person that was lecturing. And she basically offered my wife a postdoc on the spot. And she's like, I guess we're going to go to live in Israel on for our postdoc. And we were interested in doing something different after our PhD. You know, PhD is a very long process, and some people just want to do something different after that.
Yeah.
It was also when the economy was very bad. There was a lot of competition for postdocs in the United States, and it was just a good time to like kind of leave the United States and try some new things. And I had been there before, and I was fascinated by, you know, the people there and the culture and you know, the conflict issues there, where I wanted to learn more about it, and I wanted to experience all the different you know, people that lived in that area. So yeah, we got a postdoc. And I ended up getting a postdoc also there. We both were at the Weissman for 3 years. And from a sociological point of view, if you're interested in ethnography and learning about coexistence and conflict, it was just an amazingly fascinating place. We met so many people from, you know, we met Palestinian people, we had Druze friends, you know, Arab Christian friends, religious, non-religious. There's just so much there, and it's so different from the United States, which is an unbelievably fascinating place for me. Also a very scientific place to be. I think they have the highest number of PhDs per capita of any country. So it's a very, very interesting place if you want to explore it. So that's why we ended up going there. It was a fascinating experience to be there for 3 years.
Yeah, I think sometimes people don't realize that Israel is high on the science IQ. Like a lot of people don't think about it in that way. Probably because of the conflict. But yes, Israel does have a lot of scientific merit there.
Yeah, it's very.
So that's awesome. And do you mind if I ask what kind of scientist your wife is?
She a very similar kind of thing. She studies fluorescent marine organisms. So things like fish that give off different colors underwater, other kinds of organisms. And her stuff is actually very famous too. If you want to look up fluorescent sharks, just Google fluorescent sharks and you'll find her group's research in CNN and PBS and other places. They were picked up a couple of years ago because it's very intriguing, like glowing fish and glowing turtles. So that's her research. So if you ever find anything about that, that's her lab and her coworkers that are working on that stuff. So in Israel, she worked on some cancer related projects though.
Okay, well, let her know if she wants to be on the show.
Oh yeah, I'm sure she would. She's also helping me teach some classes too. So she's been involved in this kids project along the way as well.
Oh, a husband and wife team doing this. That's awesome.
Mm-hmm. A lot of
Christina said, thank you. This is so helpful. I'm pretty sure you're going to hopefully get some people hitting you up about doing this in more classrooms, especially virtually during this pandemic.
Of course, yeah.
So that is really, really cool that you guys found each other and that you are doing similar projects. Melissa says she loves bioluminescence. Yeah, I actually was on a research boat in Alaska.
Oh, wow.
And when you're there at night in the middle of the water and there's no lights from the city,
wow,
it's beautifully dark. And so we had some bioluminescent, I don't know what it was. I'm pretty sure it was either algae or some really small organism.
like dinoflagellate or something. Yeah, wow, I've never seen that. I've always wanted to see that, but that's really cool. You got to see that.
Yeah, it was awesome. And it was also nerve-wracking for someone from a very city place, being on a research boat. Yeah. But, opportunities, I like to tell students that there's so many opportunities out there, especially in STEM, that, just to be open-minded and to go somewhere you never thought you might go or try something you never thought you might try, because you never know what's going to happen.
Yeah, and I do tell my students that, my college students that is something, because science is so international, you could do a PhD in another country or do a postdoc in another country and further your career. And yeah, that's just another dimension of being a science person.
Okay, yes. And so at the end, in about probably another 20 minutes, there was a question about sharing your email. So the woman who asked Christina, she is a teacher here, and I think she wants to share your information with her other education resources.
Okay, cool. Yeah. So the way to find me, I can tell you my email, but if you just simply Google Biochemistry Literacy, you'll get my website, and I have a Facebook and Instagram and everything else. So Biochemistry Literacy for Kids. But my email is, you can just, I guess, do my name, Daniel Bennett, Bennett, Fried, spelled like fried, Fried, at Gmail.
I keep saying fried, and it's
it's fine. Everyone calls me Fried. I don't care anymore. It's fine. But just the easiest way is just to find my website, Biochemistry Literacy. You can contact me through the website. If you type in kids biochemistry or whatever you remember, you'll find the website. We're actually redoing the homepage this week, so the homepage is going to look really fancy next week. But just simply contact me through there or through one of the Facebook groups or whatever else. Or Instagram is fine also. But it's very easy to find the contact.
I just shared the Biochemistry for Literacy, or Biochemistry Literacy for Kids.com.
Okay, cool. Thank you so much. Yeah, and I love working with schools. We have schools that are using it. It's really wonderful to see it deployed in schools. I want more schools to use it. But what's very easy is for homeschoolers to use it. So that's what's kind of gotten some traction this year in COVID. Yeah.
Yeah, I mean, I obviously have some time to go, but I'm hoping to get him interested in STEM early, so that he has a world of opportunities for him in the near.
I'm looking forward to it in years. He can take some of my classes. Yeah.
Yes, absolutely. Right now, we're just working on him saying "mama." That's all. That's all.
The kids love these models because they're like Legos for them. So it's just very easy to get them involved.
Right. Yes. And so I wish that you were teaching that when I was learning biochemistry in college. Even with models in college would have been a much easier.
I mean, this is my dream curriculum. I don't follow standards really. No one tells me what to do. I'm not funded by anything. So it's literally, I'm just doing what I think should be done, like from the purest sense of, what my personality would want to develop and what I wish that I had as a kid. So it's a very like idiosyncratic project, and it's a very pure expression of how I feel about science. It's not controlled by, you have to do this time. What's the developmental, what do people say is developmentally proper? It's just what I've found in 10 years of doing this, like what's possible, what kids want to know. And looks like you got them to sleep.
Yeah.
That's what biochemistry will do eventually.
Right. I wasn't going to say it, but biochemistry in my class at least was a lot. But yeah, it's one of those things that hopefully he'll learn it at 10 and he can teach me it all over again, because I don't remember half of it at this point.
I relearned it a few times too. I had a good biochemistry teacher in college, a very good organic chemistry teacher too. But yeah, then you kind of like forget it because you don't use it, and you have to like learn it again. And then when you become a professor, you have to learn it again and able to teach it. So you learn it a few times, and eventually it sinks in.
Yeah, I feel like that's what my mom always said. She taught, well, she got her degree in biostatistics.
Oh
So she
wow,
taught math.
wow,
And, you know, it's one of those things she would always say, I had to go through the book and relearn math just to teach math.
right.
So I totally understand. And like biology is my favorite thing. Animals are my favorite thing. So
Mhm.
I always say I know a little bit about a lot of animals
Wow.
instead of just learning about one. But yeah, it's one of those things that if you don't teach it, you might lose it. So it's good to teach and good to
Yeah.
relearn it. So what do you see as the future, or what do you hope is the future for you in biochemistry literacy for kids?
Yeah, so the project was because it was never funded. It wasn't ever really an academic project. It was really like a personal project, actually. Even like publishing the papers, I paid for the publication fees myself. It's turned in the idea is now to make it kind of self-sustaining so that I can keep doing it. So we have parents that get involved in the program. They pay for access. I run these classes for a very like reasonable price, basically. But it's to help keep the website going, fund what I need to do, like make the access to the curriculum better. It was an expensive project, so it's actually starting to kind of become sustainable for me now. It's really nice after all these years of putting so much time and effort into it that it's actually looks like it's going to survive now, which is what I was hoping for all these years of, not really knowing what was going to really become of it. And now we do have like a couple hundred families using it. We have schools using it. And I just want more people to use it. And the more people that kind of become a part of it, I'm going to create more material. I have so many ideas for like doubling the amount of lessons. Right now we have 25 units, which is going to be enough for a whole year. It covers a huge swath of general chemistry, organic chemistry, and all of biochemistry. And we even, from talking to the kids, running these classes, which I run a few days a week now, these kids are asking very high level questions. They want to know about the orbital shapes of things. They want to know why does the octet rule exist? Why do electrons populate the orbitals in certain ways? They ask these amazing questions. So we need more material. So I want to just keep expanding the material, what it is. I'd love to have more collaborators. Actually, one of the parents who kind of got on about half a year ago, she's actually teaching the stuff herself now online. So she's like kind of almost like a partner now in teaching it and spreading the ideas about it. So I would love more collaborators. I'd love more schools, and I work directly with the schools to like if they need certain if they have ideas for certain lessons or they want some emphasis. I do work very closely with the schools. They're kind of also like partners in a way for me. So I just love more collaboration, more students using it so that it can become self-sustaining and become more than something that handful of people are using. I'd really love everyone to know about this and for it to be really widely used, because if everyone uses this, one of the things that happens, especially in the public schools, is we discover kids who didn't really have any scientific things going for them. They were just regular kids. They didn't know they had anything to do with science. And we discover these kids that are going to be amazing when they're older, but nothing would have happened to them unless they had this experience. In Jersey City, where there were a few kids that just stand out for me, like we discovered these kids. Now these kids are on this different trajectory, and that's the most amazing part of this. There's always going to be the smart kids, and they're always going to be, their future. They have a good future, but then there's these other populations where you give them this opportunity, and you're finding something. It's like you're mining for gold or something. And it's amazing to see that. And the teachers are like, we didn't know this kid was going to be a science kid, but this like kind of grew in them so quickly. So there's always all different reasons why I want this to get expanded.
That's awesome. And that's very true. As a person who grew up in the public school system, it was actually my junior year teacher who my school is on Alameda, which is like a man-made island.
Oh, wow.
And we had the back of the school went into an estuary.
Wow.
And so we were able to get waders and go out and like study the estuary. And that is the reason, that is the reason, somebody rang the doorbell. Anyway, that's the reason why I got into science more and more, learning more about ecosystems and animals. Wow. And it's because I had a teacher who opened my mind to it, where I never thought anything of it. You know what I'm saying? So it's really cool that these things are available and that you're doing it for the public school system. Yeah. And sorry, there's people outside. It's always something. But anyway, I digress. It's really good what you're doing. I did have a question from the audience, which was, what's the difference between organic, inorganic, and biochemistry?
Okay, yeah. So I do cover the sort of different aspects of all three of those in the program at this point. I have a PhD in organic chemistry. Most of my training is more biochemical. I'm technically a chemical biologist, which is a whole nother story, what that is. But so organic chemistry it tends to be the study of small organic molecules and their transformation. So how do you make a drug molecule, for example? How do you synthesize a medication? That's organic chemistry. The chemical reactions to create small carbon-rich molecules. Inorganic chemistry deals with non-metals, non-carbon things. So if your molecule has a metal in it, it's technically you'd be in the field of inorganic chemistry. So there's also a field called bioinorganic chemistry, which means a biomolecule that has metals in it. So there's all kinds of crossover. And then biochemistry, which is my emphasis, is the study of the molecules of life. So basically the great biopolymers that exist here on Earth that make up life, like proteins, polysaccharides, DNA, RNA, lipid membranes, things like that. So the great and complicated molecules that really only life utilizes. So biochemistry is the chemistry of life and of the cell. Okay,
yeah, thank you for doing that explanation. I would just say, inorganic or organic is carbon-based. That's just how I always looked at it, and inorganic metal. So yes, thanks for that. And then Steve says he agrees with you, talked about with teaching, that he discovered with the kids he teach at the Boys and Girls Club in Seattle using his STEM teaching platform is, I guess, the same as what you're learning, is that they're open to it and that you never know where you're going to find a future scientist.
Of course, yeah, it's really amazing. I mean, when I was first started the program, that's what struck me. Like going into these schools, you just see it's really amazing to see that happening, where a kid who maybe they were an arts kid, or maybe they weren't really have any emphasis, and then they discover this passion. It's really cool to see that.
It is. It's really interesting to see when their mind is expanded. Yeah. And they see an opportunity that they didn't see before. They look at things differently. So that's really cool what you're doing with the biochemistry and the handheld models. So when you're doing the at-home teaching or some of the students in other places like Australia, are you sending them the models to build?
Yeah. Yeah. So the kit is actually, you've probably seen those kits, people using them. The owner of that company is actually sort of a collaborator now. When I made the first documentary showing what I did in the Jersey City schools, I sent the documentary. By the way, the documentary was made by a very dear friend of mine who was a childhood friend he does production work in Manhattan. So it was very amazing to have someone in production, like kind of basically just volunteer and get be able to express what I'm doing in a professional way. And that's opened the doors for me to have that documentation. Because before that, I was kind of just operating basically in darkness. I would do these programs and no one would ever see what I did. And having that video made really just changed it for me. So anyway, I sent this video to all different people, and I sent one to Molymod in England, which is the company that makes the models. And his response was really amazing. And we started to talk, and I actually I helped him do a presentation at a conference once. And then basically he creates a custom kit that's like designed for exactly what I'm doing. So it's an official kit that you can buy only through me at this point. But it's an official special custom kit that gets sent around. Yeah, Australia is able to access it, and anyone in the US and Canada, I can get it to them. Other parts of the world, I'm going to need some help to get them. We can get them other places, but usually it's just the US. Yeah. But it's more than just the modeling, though. It's the actual, the work that was put into this is really in these presentations, the visualizations, the videos, and the modeling is just kind of like is a way of making more active learning environment. So between the visualizations that I created, those took a long time, the modeling, computer modeling, all the different things come together to make the experience.
Awesome. So what is the name of the documentary?
Oh, you can find it on the website. If you just go to the website again, just scroll down, you'll see the first documentary. They're doing unfortunately, they're doing construction this week on the website. So part of it, the other documentary is missing. But if you go down to my YouTube channel, on the bottom of the screen, there's a YouTube link, or if you just Google YouTube Biochemistry Literacy, or Google my name, you'll find my YouTube channel, and you'll find all kinds of stuff there. You'll find the other documentary, which was made in a Montessori school. So I have a bunch of videos about this Montessori school, which is the second documentary, and then a bunch of kind of training videos and other videos about my project. So the YouTube channel is nice. You can find all kinds of other things there.
Awesome.
Or just email me and I'll send you links to things.
Okay. Well, I mean, if your friend in Manhattan ever wants to collaborate, because I think all of this should be like on Netflix or something, or streaming or TV.
Yeah, so, we actually tried to have a higher level person produce a documentary on it, but they were too busy at this point. But we do have some connections that hopefully one day we'll get some better, real good, publicity and maybe a Netflix or something. That'd be really crazy. So.
Yeah, I don't want to step on your toes. I think you should have your own show, but I would love a show where I get to talk to scientists and people in STEM all day.
It's very needed. It's a needed thing. Yeah, that'd be great.
Yeah, so tell your friend about me.
Okay.
But yeah, so we are getting towards the end, and I wanted to give you the opportunity to say any last things that you wanted to say about what you're doing or how anybody can get in touch with you.
Okay, sure. No, you covered a lot of great questions. I don't have too much else to add at this point. Kind of showed you everything, but yeah, I can't emphasize enough. It's very easy to get involved with this project. I have people joining every day. A lot of homeschoolers, but you don't. The one thing I want to say is that you don't need to be a Mensa kid. You don't need to be a science nerd kid. This was made for anyone to do, and this was designed in regular schools that have regular teachers and regular everything. Doesn't have to be a rich school to do this, so you don't have to have tons of money to buy. There's nothing to buy that costs a lot of money. So I wanted this to be something that anyone could do, and don't be afraid that you can't do it. If your kids are 7, 8, 9 years old and older, it's gonna work. It almost never works. It almost never doesn't work. And you just be really surprised that it really turns on kids to science. And you don't have to be a scientist yourself. The parents don't actually teach it. So the kids more or less teach themselves, which is another thing that you have to realize. Because the one thing about adults, and adults are great, but just like me, like if I wanted to learn a new language, I really can't. Like I tried a few times, I can't learn a new language. It's just too late for me. But the kids, that's what they're designed to do. They're designed to learn new languages, and chemistry is a language, science is a language. So that's why it's called biochemistry literacy. I approach it from a different perspective, maybe a linguistic perspective, and they learn it the way you'd learn a language. And they can do it. They really can. So I would tell everyone not to hesitate to look into it and see if their student would like to do it. And the younger they are, honestly, the easier it will be.
That's really cool. Like, yeah, I wish I can learn Mandarin and French, and I have tried to learn Mandarin and French. It has not been the best of the world for me, so I totally understand. We
did that with our 3-year-old. He's had Chinese babysitters his whole life, and so he understands Mandarin actually. And that was a very important thing for me because I knew how bad I was at language, and I didn't want him to get stuck like that. So he's had a language experience, a bilingual experience. So yeah, he watches like Chinese TV, and he'll like tell me like things in Chinese, like I don't speak Chinese, I'm sorry, like I don't know what you're saying. So but they can do that. Yeah, so
yeah, I played Baby Einstein for him for the music. He's only 2 months. Like he was born in November, but you know, I still
Oh,
try to play
registering that.
like different language stuff in the
Yeah.
background just to be like,
Yeah.
hopefully in the background you're learning this.
Yeah, and the fruits of those labors come out later, you know, much later and in unexpected ways, and you'll just realize, oh wow, he really did learn that. Like I didn't realize that he was going to learn that. And similar things with anything, honestly.
Yeah. Well, Christina said she would love all the links, so I'll make sure she gets all the links for you.
Okay, cool.
But I found him on Instagram. If you guys
I'm so happy you found him on Instagram.
Yeah, his name is Daniel.Bennett.Freed on Instagram. So that's how I found him and I saw all the amazing things he's doing. But other than that, I will make sure I share all the links. So that
and I think if you Google biochemistry literacy, you get a whole page of my stuff. So you'll find it if you just remember that, or even kids biochemistry, you get me, and you get a bunch of my other links and videos and stuff. So anything with kids and biochemistry, you'll find me easily. You can contact me.
Yeah, I don't think too many other people are teaching kids biochemistry at this point.
No, I don't see. I wish I could. I don't seem to have any competitors.
No, you don't, which is awesome. Yeah. Well, I want to say thank you for joining me this evening. I know it's late on your end of the coast.
It's fine. No, I'm really happy. So grateful that you wanted to talk to me. Thank you so much. And thanks for everyone for listening to this conversation.
Yes. So I'm going to convert it. I will put the video on YouTube and then I'll send you that link and then I'll take the audio and put the audio on the actual podcast, which is on all the sites, Apple, iTunes, Google Podcasts, iHeartRadio. I'll send you all of that so that you can have that as well.
Thank you so much. Wow.
Yes, and but I'll let you have your evening back. Thank you again for joining me on In the Know with Cat.
Thanks a lot, and good luck with bedtime there. It looks like he's off.
Yeah, he's done. Thank you.
Thanks again. Really nice to meet you. I'll talk to you soon.
All right. Bye.
Okay, bye.
Thank you, everyone, for joining us tonight with In the Know with Cat Bobino. My super awesome co-host fell asleep partway through, which is fine by me. Let's not wake him, so let's keep him asleep. But thank you, everyone, for joining us and having all these amazing questions and comments. Very lucky to find him. Like I said, I don't think anyone is teaching biochemistry to our elementary age students. So I think it's really cool. Thank you, Christina. Said thank you so much, Dr. Freed. I'm sharing with my Montessori school. So, you know, thank you for all of that. And make sure you join us next week. I'm going to be talking to a woman named India Brown. India Brown on Instagram is _Cheek Geek. And she is a research scientist with a master's degree in biotech. She's a STEM advocate and an HBCU grad. She's also the owner of Cheek Geek Custom Creations and the founder of Cheek Geek Meat. So this is someone else I found on Instagram, but she does things on being a nerd, travel, hair, foodie, self-care, and fitness. So she is going to be my guest next week on the In the Know with Cat Bobino. So I hope you join me Wednesday at 6 p.m. And I hope you have a good night. Bye.